Here, discrete time sequences. The result of sampling an analog signal is a sequences representing the signal sample. Okay, here the input signal that is in the form of analog signal. Okay, that can be sampled. That can be sampled. The sample output is we call it as sample. The sequence that results depends upon the signal that is sampled. Here we know that x of t is equal to a cos 2 pi ft. A cos 2 pi ft. Okay, when we sampled, we get the sequence as x of n t small n, nt a cos 2 pi. In the place of t, you can add n into t, capital N. Where n is 0, 1, 2, 3 intervals. Okay, for simplicity, we write ignore this t, and we will write here x of n is equal to a cos 2 pi n into t. Here we know that what is fs equal to 1 divided by t. Fs is equal to 1 divided by t, and substituting theta for 2 pi ft. Then what we will get here? X of n is equal to a cos 2 pi n into t. What is t here? Fs is equal to 1 divided by t. Here, Fs is equal to 1 divided by t. Here I can substitute here. A cos 2 pi f into n divided by fs here. T is equal to what? 1 divided by fs. We written 1 divided by fs. And that is equal to, here we know that. What is theta here? 2 pi ft. 2 pi ft. Okay, that is theta, right? That's why a cos theta n. Okay, the quantity denoted by theta is called the digital frequency. Theta, the quantity denoted by theta is called the digital frequency. Okay, the unit for the digital frequency is radians. Okay, the general equation that relates the digital frequency to analog frequency is equal to theta is equal to 2 pi f into t. Theta is called as here. Theta is called as digital frequency. Okay, t is here fs, 2 pi f divided by fs. Okay, what is fs here? Fs is sampling frequency. Okay, one more sequence we discuss here, that is called as complex exponential sequence. Okay, this sequence is called as sinusoidal sequence. The sequence x of n is called as sinusoidal sequence. But here one more is complex exponential sequence. That is p of n is equal to e raised to j 2 pi n divided by n, where n is an integer. Here, a sequence that repeats is called a periodic sequence. Here, what is meant by the periodic sequence? Anybody? If you consider some sequence, I will write here 1, 2, 3, 4. Yeah, what is the periodic of this one? I thought you have studied, right? Periodic sequence. Periodic means the same sequence for year 0, 2, 0, 1, 2, 3. The next 4 sequences are same again 1, 2, 3, 4. Same sequence is repeated again 1, 2, 3, 4. Again same sequence is repeated here. Here also same. That sequence is called as periodic sequence. A sequence that repeats is called a periodic sequence. Periodic sequences result from sampling periodic signals and satisfy the following relation. X of n is equal to x of n plus n. Just remember this. Okay. Then here the frequency response. The frequency response associated with a time domain n point sequence x of n can be determined by x of e raised to j theta is equal to summation of n equal to 0 to n minus 1 x of n e raised to minus j n theta. Just remember the frequency response of the x of n here for n point sequence. Okay, where what is theta here? Theta already discussed is a digital frequency. The unit for this one is radians. Okay, the theta will range from 0 to 2 pi radians. 0 to 2 pi radians corresponding to the analog frequency from 0 to fs hertz. Okay, then we go for the DFT, and next topic is DFT and FFT. Already we have
Sir. Sir, it's not audible.